This is Dr.Rajesh Khattri from Oriental Engineering College, the Departments of Mathematics. The idea about the Poisson's distribution, which is helpful in the engineering mathematics. Introduction. Poisson's distribution was basically given by the Siemens Dennis Poissons in a discrete probability distribution. He finds the probability for the number of events occurring for the fixed interval of the time of the space, occurring as a constant mean rate of the independent since for the last event. The Poisson distributions can also be specified for the distance, area, or the volume too. The the key points which basically I will be discussing over it is probability density functions, which is basically used in the staticals, denoted by EDF, and the next is PDF, basically used for the resembling bell curve in the probability outgoing for the curve in the increasing or the decreasing functions. The discrete variables will be the continuous for the variables in the infinite values. It is also being calculated for the potential risk rewards, including the potential or in the particular security or in the protocol follow. The Poisson distributions as a limiting form in the binomial distribution. It is containing the 3 points. One is when n tends to infinity, it is used in the hit and trial methods. When for moving for the large quantities, including the small 2, then p tends to 0 and q tends to 1. Third is when the average number of successes is equal to the positive finite quantities, that is m, where m is always treated as a parameters of the distribution. Now what exactly the Poisson distribution means? It is nothing but a tools taken to predict the probability of the certain happenings or not happenings in the fixed interval of the time given as per the occurrence. The probability distributions can have the validity for the integers and can be represented on the curve 2 on the graph on the horizontal axis x-axis, and mu can also be taken in the expected number of events occurrence given according to the conditions. Here lambda is equal to 1 and lambda is equal to 4 and lambda is equal to 10, which is being laid out, shown you for the graphical representations in the 3 phases. Now the characteristics of the Poisson distribution. It is again given in the discrete probability distributions, which is occurring for the whole numbers, that is 0, 1, 2, 3, and the value of the p and q depends. Basically it can be denoted as q minus 1 or p minus 1 depending upon the infinite largest, and the parameters can also be distributions at m is equal to np. For the entire distributions can be known as subparameters. The shape of the Poisson distributions can again be treated in the positive variance. It can be as skewness, dismiss, or in the increasing order or in the decreasing order depending upon the figure as illustrated. Constant of the Poisson distributions can be given as unders, which has been given as, where mean x or m is equal to np, variance which is sigma square equal to m, standard deviations which is denoted as under root of m, or in standards can be written as 3 plus 1 upon m. Then the moment of the coefficient of skewness is root m, and moment of Kultos is written as beta to the base 2. Then the equality of the mean variance is an important characteristics of the Poisson distributions, where the mean and the variance are equal to the mean, which is equal to the variance. Now the roles used for the examples of the Poisson's distribution. First is biologically in the bacteria calculations. It may be in the increasing or it may be in the decreasing orders. Insurance problems for typing the errors, for incoming the calls, defective blades which is being manufactured in the factories. It may be in the increasing or it may be in the decreasing defective. Death in the town or in the cities. It may be in the accident or it may be in the any consequences. And suicide case depending on the data structures calculated with respect to the years. Applications of the Poisson distributions formula. Fitting of the Poisson distributions is basically calculated. Let us consider the problems. The company is manufacturing the sum of the screw which is having the defective of 2%. Now I want you to calculate the packet 100 screws containing this class. The probability P is given to you. The defect is the 2% which is been denoted as 2 by 100. In the usual manner, it can be written as NP which is equal to 2 by 100 or N is equal to 100 there. M is equal to NP. It can be calculated which is equal to 2. The further calculations is done in this formations for the 0, 1, 2, 3 and 4. And finally I got the result. Between the hours of 2 p.m. to 4 p.m., the average number of the phone calls per minute by the outcome of the force companies 2.5. Find the probability of the doing the one particular minutes, which can be 1 no falls, 2 exactly 3 calls, exactly 3 calls, or exactly 2 calls, or at least 2 calls. Any of the things, either it is possible. On this stage, let us move with the another things. I'm talking about the laser printing machine. Average number of the mistakes per page is 0.3. What percentage of the page will have? First, no match. Second, 1 mistake. Third, 2 mistakes. The M is given here is 0.3. The probability of the no mistakes, that means 0. The probability is calculated. Substitute the values. I got the result, that is 0.748. It can be calculated further. It can be written as in the order 74.08%. For the second, I again substitute the values in the formula. I got the result, that is 0.222, which further can be written as 22.2% of the pages which is having no mistakes. The probability of having the 2 mistakes, it is being calculated again by the formula. Substitute the values, calculate it, we are getting 0.033. It shows that 3.33% of the pages will have 2 mistakes. Now, fitting of the Poisson distributions, it basically depends upon the 4 points. First is Nx is equal to Fx upon N. Secondly, Em, which is basically known as a reciprocal, which is being calculated by the antilog. We completely, third point, the compute the probability of the successful is being calculated as 0, 1, 2, 3, 4 as the order it is being given to us using the Poisson distribution formula. P of x is equal to e raised to power of m followed by m raised to power of x upon the n factorial. The expectations of the theoretical frequencies can also be calculated by multiplying the e's probability by the total number of frequencies given, that is total 12 or 14, depending upon the frequency given to you. Okay. Okay.